like either increasing or decreasing, and we're going to transform them. So we're going to bring those transformations back that we did in chapter 1 of this course, you know, with the stretching, the compressing, the shifting, vertical translation, all that fun stuff. So here is a very busy, seemingly overwhelming equation of all of the stuff or transformations that could be potentially added in today. So just a reminder, yesterday, the base equation for an exponential function that we saw was that guy, right? C had to be positive, and your exponent had to contain a variable. Now you will see we have added back in that A value that we saw in chapter 1. We have added in a B value. We have added in an H value, and we have added in a K value. We saw those 4 letters in chapter 1, okay? A, B, H, and K. The difference between this and chapter 1 is that these guys right here, the B and the H, are now an exponent or part of the exponent. All right. So what we're going to do is we're going to take a trip down memory lane here and remind ourselves what each of those letters actually means. And you know this already. It's just sleeping in your brain. We're going to wake it up. Okay. So if A is negative, so that's this first term right here. So if this leading coefficient A is negative, that means there is a vertical reflection. So imagine you have an increasing exponential function. A vertical reflection would look like that. So what's up comes down. All right. And also whatever the number A is, that represents a vertical stretch by that factor. So we don't mess with A. Remember how I said so often we flip the B? We don't do anything to A. If A is 5, that means we stretch it vertically by 5. No messing around with reciprocals. Okay, so A is all about vertical reflections and stretches. Okay, B, so now I'm talking about this number in front of the bracket up there. If that number is negative, that's a horizontal reflection. Okay, so horizontal reflection means whatever is left goes right or right goes left. We reflect around the y-axis. Okay, and then also B, whatever that value of B is, represents a horizontal stretch. So we're either stretching or compressing horizontally. And that's where you have to flip the B. Remember? So if B was 2, that actually means we're stretching by only 1/2. That means we're actually getting smaller. And the other way, if B is 1/8, that means we're actually stretching by 8. You always flip the B to get that horizontal stretch. Okay, and then H is just the horizontal translation. So that's this number right here in brackets with H. That's how much we shift it left or right. Remember that? And it's always the opposite symbol. So when we pull it out, we take the opposite symbol. So if it's a -2, that means we actually go to the right 2, +2 to the right. And finally, remember how I said in chapter 1, if K is on the right, the symbol is right? Do you guys remember that? Okay, so K, this number at the end here, that's what we shift vertically. Okay, so that's going up or down, and we don't mess with that symbol as long as K is on the same side of the equation as all the other business, all right? So that's just a review of stuff you already knew. Let's just look at a couple of equations here, and we're just going to identify the transformations. So again, we have done stuff like this before. We're just going to list what's going on. We're not going to graph it yet. Okay, so I just travel left to right, and I look for things that are changing my graph. Now, this is immediately where it already gets troublesome. A lot of students think that that is A, because it's like the leading coefficient. And so the number right out front is our A or our vertical stretch. Wrong. This is not our A. This is our C. And the way I know it is C is because the exponent is directly attached to the 4. So the exponent will always be directly on C, which is the case here. Okay, if this were to be A, don't write this down. it would have to look like that. Like that would be your A. Am I making sense? Okay. So that 4 is actually our C value, and that C value doesn't tell us any transformation. So 4 is my C. Now I move on to the next number, this guy here, the 2, what letter is that? B, right? Just look at the equation I gave you up high. Okay, whatever letter is in front of that bracket, that's your B value. So I have a B value of 5. So I'm going to write that down. Okay, I'm going to say B equals 5, and, or sorry, not 5, pardon me, 2. And then we're going to list or state what that actually means. So if B is 2, that means we have a horizontal stretch. And remember, whenever we talk about stretches, we have to say by a factor of, what am I stretching this by? 1/2. Very good. You got to flip that B. So this would actually compress or get smaller by half, not double. All right, then I move down the line. X is X. I skip over that and I go to my next value. The guy in brackets is my H. All right, so that's my next thing. I have that H is equal to -5. Actually, technically, H is equal to +5, right? Sorry, I didn't flip the symbol. Duh. All right, so that means a horizontal translation 5 right. Okay, I flipped the symbol. It's actually positive. That means we go to the right. And last but not least, I have this guy down here. That big fat number of the end at the end is my K. All right. So I have K equaling -6. No touching the symbol there. And that just means a vertical shift or vertical translation. I don't care which word you use. And that means 6 down. Okay. So that was a pretty basic one. Okay, we are now going to get a negative in there or a reflection, and we're going to have some fractions too. See if we can figure this out. All right, my first number I see is 2/3. What does that represent? A, that is my A. Very good. So I have an A. Let's talk about it. So my A is equal to 2/3. What does that mean? That is a vertical stretch by a factor of 2/3. 2/3 stays 2/3. No flipping A. It is what it is. All right. 1/2. That's my C. He's fine. That's not a transformation. We don't write him down. That's just the base. All right. The next thing I run into, though, is just this guy right here. Okay. So someone tell me, what letter is that negative actually attached to? B. Okay. It's actually like this is a -1x. We just don't see the 1. Okay. But my B value is actually -1. So that negative, my B being -1, tells me that I have a horizontal reflection. That negative means there's a reflection. And then because the actual B value is 1, that's nothing, right? That's a stretch. So I have a stretch of 1. Well, timesing it by 1 won't change it. So it's really just the negative that's applying the transformation here, okay? We have a horizontal reflection. And finally, I see a 9, +9 at the back. What does that tell me? K equals +9. That means it's a vertical shift or vertical translation. And that is 9 up because it's positive. Okay. Last one, what I wanted to do here was give you a negative again, but also give you a fraction in your exponent. So that's why this one's a little bit different. Okay, first things first, the first thing I see is -2. That is my A value. So I've got a couple things going on for A. So A equaling -2 means two things. The first thing, the negative, means I have a vertical reflection. And the 2 means I have a vertical stretch by a factor of 2. Right? We don't flip the A. 2 is 2. So we would be doubling the size of this graph vertically. It would be twice as tall. Okay. And then I get to this number. That's my C. He's fine. Don't bug him. But then I get to this guy here. Anyone want to tell me what that's telling me? Like, what letter is that? And what's the value of it, Kai? Yeah, so my B value in the equation is actually 1/4. Okay, it's like this is 1/4 times X. That's the same thing. So I see a number in front of X, it's 1/4. Okay, B represents horizontal stretches. So that's a horizontal stretch by a factor of what? 4, right? You got to flip that B. We would actually becoming quadruple the size if we stretch horizontally. Okay, so I just wanted to bring all that stuff back. Now it's back. We woke it up in your brains. Now we are going to actually start sketching. Now you might groan like, oh my gosh, how do we do transformations on a curve like that? And you're having nightmares back from chapter 1. Here's the really, really, really good news. I'm only going to make you find 1 point. Just 1 point to graph. All you have to do for me is find the y-intercept, that point. Okay? It's also important to know where your asymptote is, though, because that's your barrier. So that's important to know. Okay? And then you're just going to have to visualize, is it increasing or decreasing? All right? So I'll show you what I mean. So here we go. We have f of x, which of course is the same as y. Y equals 3 times 2 to the power of x minus 4. Okay, just to practice one more time, I'm going to write down what I have going on here. I'm going to write it very quickly, okay? First thing I note is that A is equal to 3. So I have a vertical stretch by 3. I'm doing very shorthand here. So I have a vertical stretch by 3. The 2 is my C. He's fine, but that tells me it's increasing. So that's important. So when you're drawing your graph, you need to know that this would increase. So your curve is working its way up. That's still important. Okay. X is X. There's no B. There's no H involved with X. So the only other point I have is that K is -4. And that's very important because this will change your asymptote. Because now I know I have a vertical shift 4 down. And this vertical shift 4 down affects your asymptote. So essentially our asymptote will be 4 down. That's very important. Okay. So just some other notes here. I'm going to note there are no reflections. So my graph won't be reflecting up, down, left, right. And it's increasing. So I'm just writing some important notes for me to visualize when I actually draw this. Okay. We are going to find the y-intercept. Where is this graph going to cross the y-intercept at? So the way we find our y-intercept is by replacing x with 0. We've done that before a million times. Okay, so here's my equation. Remember, you can always replace x with y. So I have 3 times 2 to the power of 0 minus 4. Okay, make sure you follow the rules of BEDMAS. This is 3 times 1. You're going to do your exponents first. 2 to the power of 0 is 1. And so I have 3 minus 4, which is -1. So my asymptote, the only point I have to draw is at 0, -1. Okay, so let's go over here. First things first, I'm going to draw where my new asymptote is going to be. That's very important. I give you marks for drawing it in when it's not on 0. When it's at a different line. Okay, so we've shifted this entire graph 4 down. So that means the asymptote moves 4 down as well. There's my vertical shift. I just went 4 down where it usually is, right? Then my asymptote, or sorry, not my asymptote, my y-intercept is right there, 0, -1. And now I just ask myself, do I draw it moving upwards or moving downwards? It's increasing, so we move it upwards. There's no reflections. So all we did is we took that question from yesterday, or the graphs from yesterday, and shifted it down, okay? Now there is a vertical stretch by 3 with curves. Those are hard to see, okay? But just trust that when we did all this work, we multiplied it all by 3, okay? So we did apply the stretch. It's just hard to actually see on the graph, okay? So these are really the only 2 things I care about when you're graphing. Well, obviously I care about the direction. You have the right direction too, but the y-intercept and the asymptote are very important. Okay, I also asked you for domain and range. So very quickly, let's see how domain and range changed from yesterday. Domain is still the freebie because we're still far left, far right. But my range has changed because my asymptote is lower. So this means that my graph is now greater than -4. Yesterday, it was greater than 0. And then, of course, you'll always see your textbook do that at the back. That just means that the arrows go for all y values once they extend up. Okay, so that's a pretty simple one, pretty basic. We're going to add in some more. Now, again, don't panic. There's lots of stuff going on here. You just have to find 1 point. 1 point, that's all, okay? And here, I didn't actually even ask you to state all of this stuff. Okay, I just did that for the first one so we can kind of wrap our heads around it. I didn't actually ask you to do that. I didn't ask you to state the transformations that are happening. So let's just save some time and get right into it. Let's get right into the point that is very important, which is my y-intercept. Okay, we still will look at the transformations though, because we have to ask ourselves if there's reflections and if it's increasing or decreasing. So we will look at the graph or at the equation in a second. All right, so y equals -4 times 3 to the power of 0 plus 5 plus 1. So I've just added in the 0 where there's an x. And now I have -4 times 3 to the power of 5. I do my exponents first. 3 to the power of 5 is 243. I get in the end, when I multiply those two and then add 1, I get -971. Okay, so when you're graphing this, obviously we're not going to jump all the way down to -971. I don't care what you do. This is how lax I am with these graphs. Just pick a random point and call it -971. Another little memory thing. Do you guys remember when we did chapter 3 polynomial functions and we had to do like the graph curves, 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 curves? And I made you find the y-intercept sometimes. Sometimes the y-intercept was at like 64. It was the same thing. You didn't actually have to go up there. We just kind of went up, plotted it, wrote the number in, and called it a day. Okay, I'm expecting the same thing here. Just randomly pick a number or a dot. That's -971. Okay, now we have to think about what this graph is going to look like. Okay, because I see this, and that is a reflection. Any reflection I know will change the orientation of the graph. Okay, so we know also that my graph is increasing. So if I visualize the original graph, you don't have to draw this if you don't want to, it's just a good visual. All of my original increasing graphs from yesterday looked like that, right? Okay, but now this is a vertical reflection right here. Vertical reflection means what's up gets reflected down. So it's going to look like that. So I just did the mirror image underneath. Okay, so our curve is going to look like this, but also We talked about how the K value affects your asymptote. So my asymptote is actually at y equals 1 now. So whatever this value for K is, tells you where your asymptote will be. Just like in sine, cos, tan graphs. Remember how the last constant of the equation was your median? Whatever that last number is was where your middle was. Okay, whatever the last number is where your asymptote is here. So we are going to draw my asymptote in first at y equals 1. Okay, and then I need to draw a graph. We already established it has to look like that. And it has to cross my y-intercept down here. So what that's going to look like, I know I have to always approach my asymptote. So I do that. And then I just work my way down until I hit my my y-intercept down there. Okay. And remember, the original was like that, right? So we just reflected it down and passed through our y-intercept. All right, let's do 2 more because I want to do a couple with fractions with decreasing too. Okay, so right away, I'm going to find that important point, the y-intercept. So I have y equaling 1/2, 0 plus 1 minus 3. So I have 1/2 to the power of 1. Big deal. Don't need that. Okay, and because we're graphing, you can use decimals here. We're going to graph the decimal. So it's actually 0.5 minus 3. I get negative 2.5. All right. So I have negative 2.5. Now I have to ask myself, what has changed on the graph? Have I reflected at all? Are there any negatives that will cause a reflection? No, that's good news. Okay. This fraction means that my graph is decreasing because C is less than 1, greater than 0, less than 1. Okay. So this original decreasing graph, if you remember from yesterday, decreasing graphs looked like that yesterday. So it's still going to look like that because we haven't reflected. But the only thing I still need to take account of is my asymptote because everything's shifted. So I'm going to have an asymptote now at y equals negative 3. And that's the only major change. It's just shifted down. So I go over here. I go to negative 3. Boom, 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 boom. All right. And then the only point I plot is that y-intercept I found, which was negative 2.5. All right. And then we already discussed the orientation will stay the same. So kind of just start randomly up in the upper left quadrant and then extend to meet your asymptote. Okay, last one. What do we got going on in here? Okay, I can see right away I have a reflection. I have to log that in my brain because I know that's going to change the orientation of my graph. Okay, so that's a vertical reflection. I know that this 1/2 means it'll be decreasing. Okay, and then I also have a shift, and then I also have a new asymptote at y equals 3. Okay. All right. So let's find that important point. So I take x and replace it with 0. I'm just finding my y-intercept like we've been doing this whole time here. And then I have negative 0.5, right? Because 0 plus 1 is just 1. 1/2 to the power of 1 is still 1/2. And I just slap a negative in front, and then I add 3. So this time my y-intercept is positive 2.5. Oh, I forgot domains and ranges. I'll go back and do those at the end. All righty, so y equals 2.5. I'm going to go over here and I'm going to draw my new asymptote. Get that out of the way. 1, 2, 3. Alrighty, there it is. And then I have my I keep saying asymptote, my y-intercept at 2.5. Okay. So my intercept is underneath the asymptote, right? Usually, if we have an original exponential function, it's always on the top, whether it's increasing or decreasing, we're always above the asymptote. So the fact that my y-intercept is below the asymptote tells me I have a reflection, like something's flipped, okay? So that's what I made note of right here. I do have a vertical reflection. That negative tells me what's up will come down, and it's decreasing. So you don't have to do this step, but I always just like to visualize what the original looks like and then flip it. Just do a rough sketch. So an original decreasing function looks like that, but I am reflecting it. So now it'll look like that. Okay? And so that's what I'm going to go draw over here using that y-intercept I found. So I know I need to approach my asymptote up there, and then I just swing down, call it a day. All right. So pretty simple. You just got that one point to find. You just got to ask yourself if there's a reflection or not. Okay, let's just go back. I'm not going to do domains for each one because it's always the freebie. Okay, but for range, I'll do it. Okay, range here, it's always based on your asymptote. So all of my y values are less than 1. Remember, we're not looking at that guy. That's my original. Okay, I'm looking at the bottom guy. It's less than 1. Done. This guy here, look at your asymptote. I am above -3, so I'm greater than -3. Easy. And finally, last one, look at my asymptote. It's at 3, so I know for sure I'm going to have a y and a 3. And then I see that I'm underneath or less than 3. There you go. All right. Any questions? All right. I am going to write your required assignment down here. So page 354, right now I have you doing 1, 2, 3, 4. And then for number 6, I give you some special directions. I'm actually only going to get you to do 3 and 6. Okay. And for number 6, all you have to do is state those 4 things. You don't have to sketch it for number 6. No sketching involved. Just state domain, that's your freebie, your range, where your asymptote is, and what your y-intercept is. And then just number 3 is graphing. All right. And this will be due Monday, right? All right.